Okay, welcome back. We're in section 4.4's discussion. This is on logarithms and the laws of logarithms. There was a couple of questions asked, so let's dive into them. Let's start with number 3. Number 3 is a string of logs. So I have log base 2 of 10. Minus log base 2 of 35, and plus the log base 2 of 112. Okay. We're going to use a couple of different laws here of logarithms to help us simplify this without having to use a calculator. The first one says this and the bases are all the same, that's important, but if I have the log of some base, whatever it is, of something, plus the log of that same base of something else, right? Log base A of one thing, log base A of another thing. If I have this, does that show up? Hopefully, yeah, it looks like it does. I can combine this into the log base A of the product of those two things, right? The sum of two logs, as long as they have the same base, turns into the log of the product of those two things, right? In addition to that, though, we have, very similarly, you can probably recognize the similarity here. If I have the log base A of x minus the log base A of y, if it's a minus that thing, then because we're dealing with exponents here, this minus is really like a negative exponent. That y is going to end up in a denominator when I plug it into this side. So it becomes the log base A of x over y, right? And I can do pluses and minuses and have a string of them. Anything with a plus is going to end up as a product in the numerator. Anything with a minus is going to end up in the denominator. And so I'll do that with all three of these guys. Let me get rid of these laws right here. This is going to turn into a single log, base 2. The log base 2 of 10 is positive, so I have a 10 that appears in the numerator here. The log base 2 of 112 is positive, so the 112 ends up in the numerator. And then the log base 2 of 35 is negative, so the 35 simply ends up in the denominator. And that's how everything just kind of flows together there. I can simplify some stuff. This, I'm just going to cheat. So 10 times 112 and then divide that by 35 is 32. So this is log base 2 of 32. And I can figure out what that is because 32 is a power of 2, right? Let me clear some room here. If you need to write that down, write it down because it's going. So I've simplified this all the way down to the log base 2 of 32 and is looking for an answer, a value. It doesn't want this expression, it wants a value. So we can say this is something. I don't know what it is, but it's something. I can rewrite this as an exponential, but I happen to know that 32 is 2 to the 5th, right? 2, 4, 8, 16, 32, that's 5 of them. So 2 to the x equals 2 to the 5th. Well, then of course, x has to be 5. And so this entire expression is 5. Good. Let's take a look at number 4. 4 is a little bit goofy looking, but they ask you to do the same thing, evaluate the expression. They give you this log. There's no base, so you should know it's a 10. Log, again, inside that one. And then we have 10 to the 1,000. Right? So whatever happens here, the log of 10 to the 1,000, I'm going to get a value and take the log of that again, right? So I really just want to focus on what's happening inside these parentheses for a minute here. I'm going to take this log of 10 to the 10,000, or to the 1,000. And there is a rule in there that'll simplify this down pretty quickly, but that's all right. I'm going to say this can be simplified to something. It's going to be some value. My base here is 10, right? There's a whole lot of 10s in this problem. My base is 10, so I have 10 raised to the x is equal to 10 to the 1,000. So similar to that last problem, we can say, well, obviously x has to be 1,000. X is what I've called this entire expression. So this whole thing turns into the log of 1,000, right? Okay. And so I can say, well, gee, this has to be equal to something as well. Let's call that, let's just go with y. Is that off too far? Nope, it's just right. And so then I have, again, I've got this 10 because it's a log with no base written, so it's 10 to the y is equal to 1,000, but 1,000 is the same thing as 10 to the third, and therefore y has to be equal to 3, and that's what I was looking for. This whole thing at the end is equal to y, which is 3, so my answer, 3. Good. And what number was that? That was 4. Let's look at number 5. Similar with 5, I've got the natural log, so I have a base of e of the natural log of e to the e to the 125. So that's an e raised to the power of e, which is also then raised to the power of 125. But we saw in the last one, if this base, this natural log has a base of e, if I have an e in the base and an e as that, they're just really going to, the natural log and the base and that thing are going to cancel out. This is going to turn into the natural log of e to the 125. But this is the same situation. I have natural log, which is a base of e. So my base is e. There's an e here. The natural log and the e are going to cancel out. The 125 falls down, and I should just end up with 125 here. Right? If you don't believe me, it won't be the first time somebody's doubted me. Do it the long way. Say, hey, all of this junk inside here has got to be equal to x. Figure out what x is, plug that back in. You know, work it like we did the last one. All right, let's go to, let's do number 13. 13 is the change of base formula. The change of base formula says this: if I have the log base a of b, I can rewrite this as the log, whatever I want base, of the b divided by the log. It has to be the same base, but it's the log of the original base with base c now in the denominator, right? So this is the change of base formula. We have the log base 4 of 14. So in a calculator, in typical calculators, the only logs that they'll evaluate are log base 10 or log base e. You'll have an LOG button for log base 10 and an LN button for log base e, right? If you have like the TI Inspire $250 calculator, you can do other bases. The TI 92 does it, the Inspire does it. Most online algebra programs will do it, but we can use this to evaluate in a calculator that doesn't have those. But I'm going to rewrite this as log, and I can choose a log base 10, and therefore it's a log base 10 in both the numerator and the denominator. The 14 goes with my numerator, the base goes into the denominator, so it's just a log of 14 that gets divided by the log of 4. If you don't like the log, you could have chosen the natural log. Try this, do them both, they're going to be the same value, right? Whatever log base, whatever you choose here, you just choose for the bottom, but that should get you your answer. And I don't have a calculator. Oh, I've got this. Just kidding. Let me do this. I get something around 1.90367 yada 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 forever onwards, right? And then you just round this appropriately. It asks to be rounded to 4 decimal places, so 9036. The next digit is a 7, so you would round this to 1.9037. The 6 goes up to a 7. Okay. Good. Hopefully that was helpful. I will see you guys for the next one.